Okay, so let's continue with the next topic, 11.3 types of immunity. So 11.3.1 communicate about the types of immunity, passive immunity and active immunity, and 11.3.2 compare and contrast passive immunity and active immunity. So let's proceed. Okay. Okay, so 11.3 types of immunity. So there are two types of immunity, active immunity and passive immunity. Active immunity means that the lymphocytes produce their own antibodies as a response to stimulation by the antigens, whereas passive immunity means that the body receives antibodies from an external source. Okay, so for the active immunities, okay, our lymphocyte can produce their own antibodies, okay, as a response to stimulation by the antigens to fight the pathogens lah. Okay, to fight the antigens. For example, so this known as active immunity. Our lymphocyte, the lymphocyte inside our body can produce their own antibodies. But for passive immunity means that the body receives antibodies from an external source. That's mean in this case, lymphocyte cannot produce the antibody to fight against the pathogens. So we have to take the antibodies from other sources. Okay, later I will explain lah. Okay, so the difference between active, that is the difference between the active immunity and passive immunity. Okay, both of these type of immunities can be naturally or artificially acquired. So can be naturally means can occur itself lah, occur naturally in our body. So artificially, another words is man-made. Okay, usually by injection lah. We inject something, okay, inside our body. Okay, so the immunity can be divided into two, active immunity and passive immunity. So active immunity can be divided also into two, natural active immunity acquired after an individual recovers from an infection. So whenever we get the infections, when we recover from it, we already get the natural active immunity. Occur naturally. Okay, later I will explain more. Okay. So artificial active immunity acquired when an individual is given a vaccine injection. So vaccine injection is artificial active immunity. Okay, injection artificial because not naturally lah, we have to take injection. But this injection, vaccination is active immunity. Later we are going to see more lah about this. Okay, and then we have passive immunity. Natural passive immunity acquired through breastfeeding and from the mother to the fetus during pregnancy. Natural passive immunity. Okay, so for example, we have fetus. So fetus, they don't have their own antibodies. So how can they fight the disease, they fight the pathogens? Actually, the antibodies come from the mother. So the mother will give the antibody to the fetus through the placenta lah. So during pregnancy. So that is the meaning of natural passive immunity. Occur naturally, but the antibody get from the external source, not produced by the fetus itself, themselves lah. Okay, so this one natural passive, and then we have another one is artificial passive immunity acquired through an anti-serum injection. Okay, so for passive immunity, artificial passive immunity acquired through an anti-serum injection. So you must make sure you know the differentiate between these two. Vaccine injection is artificial active immunity. Anti-serum injection, artificial passive immunity. Later we will see what are the differences between these two. Okay, so these are the type of immunity lah. Okay, now move on to this one. Active immunity and passive immunity. So let us examine active immunity and passive immunity in greater detail. Okay, so active immunity The two main characteristics are antibodies are produced naturally by lymphocytes. So whenever you heard or you see the word active immunity, you must remember that the antibodies can be produced by the lymphocyte. Okay, so active immunity remains for a long period of time. So it will remain or last longer lah in our body. So this is active. That's why known as active. Okay, active. Okay, so we see the first one, natural active immunity. Okay, when someone is infected by pathogens, lymphocytes will produce antibodies as a response to these antigens. You still remember at the third line of defense? Okay, so the lymphocyte will produce antibodies. When an individual recovers from an infection, that individual will gain a permanent immunity against the disease. Okay, why? Why they can get permanent after recovers from disease? Because you remember that when the lymphocyte, T lymphocyte, okay, we have two types of lymphocyte, right? So we have T lymphocyte and B lymphocyte, right? So T lymphocyte will attack the pathogens. At the same time, it stimulates the B lymphocyte to produce memory cells. Okay, so now when we produce the memory cell, we already have the information about the pathogens. So when the individual is attacked again by the same pathogens, the lymphocyte that store memories of the pathogens, that is memory cells, will rapidly produce antibodies to react immediately against the antigen. So now we already have the antibodies for that pathogens. So when we get infected for the second time, usually we will recover faster compared to the first one. Or maybe when we get infected by at the second time, we don't have any symptom. Because we have enough antibody to fight with the pathogens because of the memory cell produced by the B lymphocyte. Okay. For example, you see here, an individual who has recovered from chickenpox or influenza has gained a natural active immunity. That means when we get infected with the chickenpox for the first time, okay, later we will not get infected by the chickenpox for the second time. Rarely rarely an individual get chickenpox 2 times. Usually once in a lifetime. Because when you have this when you have infected for the first time, you already get full natural active immunity, and then this can make sure that we will not get infected for the second time. That means we have enough antibodies to fight with the chickenpox, a pathogen that cause the chickenpox. Okay, so that's why some people say, not some people lah, I think all of us must get infected one time for chickenpox. Maybe if you during the baby year you still not get chickenpox, maybe you have to wait lah. Maybe in the adult time. Okay, for me, I get chickenpox when I was 18 years old. I think 18 lah. Okay, 18 years old. So quite late lah. Usually what we call usually during the childhood, right? Okay, most of us we get this chickenpox. Okay, depends. Okay, depends on the individual. Okay, same with influenza lah. If you have influenza, if you get infected with influenza, then later you will not easy to get infected for second times because already you already have gained a natural active immunity. So this natural active that's mean lymphocyte can produce the antibody lah, naturally. When the pathogens enter, so the lymphocyte can produce antibodies to fight the pathogens. Okay, but for the artificial active immunity, this one, Okay, to protect oneself from being infected by a highly infectious disease. Highly infectious disease means easily, easily infect other people. Okay, easily spread lah. Or known as contagious. Okay, contagious disease. And individual we can be immunized against the disease. So we can get immunization, although we still not get infected. So we prepare ourselves, we prepare our body from this pathogen. So immunization refers to the process that stimulates immunity against a specific disease through vaccine injection. So that's why we get right. That's what we get for the past 2 years, last year, right? So we have this COVID-19 vaccine, for example. So we have the immunization, okay, immunization program. We have the My Sejahtera and so on, right? Okay. So that is the way to protect, okay, or to make sure that we can stimulate immunity against a specific disease through a vaccine injection. So in this case, you have to inject vaccine. So we have vaccine COVID-19. Okay, so what is the vaccine? Vaccine is a suspension of pathogens that are weakened, that or non-virulent. So for example, for the vaccine for COVID-19, usually they will take part of the virus lah, part of virus of COVID-19, put in the suspension, okay, suspension. Then the virus actually weaken, okay, or dead or non-virulent, okay, and then make it as a vaccine. So vaccine is a suspension of pathogens. Pathogen is death. So if we have COVID-19, so we have the coronavirus lah. Coronavirus that cause the COVID-19. So we take the pathogens, the coronavirus that are weakened, maybe a part of coronavirus lah, okay, and then dead or non-virulent, and then inject. So inject into the body. So when a vaccine is injected into the body, the vaccine will stimulate lymphocytes to produce antibodies to fight the pathogens. This one that means we not get the bacteria, the virus naturally. The virus not enter our body, but we put the virus that already dead or weakened, or non-virulent or known as vaccine, inject to our body, so it will stimulate the lymphocyte to produce antibodies to fight the pathogen, so that our body can recognize the coronavirus, for example. Okay. So the first vaccine injection will usually result in a low level of antibody production, which is insufficient to protect an individual from the disease. So the first dose, okay, you have to take the second dose, and then you have to take the third dose, okay, or booster. Okay, a booster dose must be administered to increase the antibody production to a level of immunity that can protect the individual from the disease. So we have to take a booster so that the level of antibody production in our body increase, and then can protect us completely from the disease lah. So if the individual is infected by actual pathogen, so let's say after you have take the vaccine, then suddenly the real coronavirus enter your body. So now the lymphocyte will produce enough antibodies and immediately destroy this pathogen. So we already have enough antibodies because the lymphocyte already already recognize the pathogens because of the vaccine. So we have enough antibodies and immediately destroy the pathogen. So that's why the symptom will be mild, okay, maybe not so risky lah. Okay, before if we not take the vaccine, maybe can go to stage 5, can enter the ICU and so on. Okay, and then for this one, maybe you will have fever, a bit fever and so on lah. Okay, because of the we have enough antibodies to destroy the pathogens. Or maybe if you have coronavirus enter your body, nothing also happen because we have enough antibodies to fight the virus. Okay, so the example lah. Before the coronavirus, this example of vaccine that we already have. Example of vaccines are the Salk vaccine for poliomyelitis. Okay, later I will show what is poliomyelitis. BCG vaccine, Bacillus calmette urine for tuberculosis, TB. Okay, and HPV vaccine for cervical cancer. This one for female only. Because related to cervix. Okay, only female has cervix, right? Male no cervix. Okay, cervix in the reproduction system. Okay, so BCG also and polio also already taken during baby. Baby until I think there's a timetable that you have to take the vaccine. Okay, so BCG of course lah, already taken, right? So I'll show you the polio. This is poliomyelitis. Okay, poliomyelitis is called as polio. Is a viral disease caused by the virus that destroy the nerve cell present in the spinal cord, causing paralysis or some part of the body or causing muscle weakness. So related to muscle. So you see this, what happened to the legs of this these children, okay, become bent like that. It is a contagious disease. Contagious means can spread to others lah. Okay, this is affecting the nervous system and is caused by poliovirus. So the virus name is poliovirus. So usually before this disease, no treatment, because at the time the scientists still cannot find the solution to solve this problem. So after they have this vaccine, okay, they know the vaccine how to protect the people from this disease. So they have the vaccine. Okay, vaccine. Give the vaccine from the baby, and then now the poliomyelitis case become decrease. Become decrease because of the vaccine lah. Okay, and then next one is the tuberculosis. Okay, tuberculosis. Okay, caused by bacterium known as This one for your information lah. Okay, Mycobacterium. Okay, bacterium tuberculosis. This is the name of the bacterium that cause the tuberculosis. So this tuberculosis actually affect lungs. Affect the lungs. So that's why you see the symptom, coughing up blood, chills, maybe become cold, okay, fever, chest pain, and fatigue. So this one also contagious. Okay, can be spread by if you infected by the droplets from the coughing. Okay, you also can get infected with tuberculosis. Okay, this one also we have the the vaccine. Okay, vaccine BCG. BCG to protect us from this lah, tuberculosis. This one also taken from baby. Okay, we have the timetable to have this vaccine. Okay, next one we have the I forgot the cervix, right? Cervix cancer. Okay, cervical cancer, right? This one. Okay, this one HPV vaccine for cervical cancer at the cervix, right? So we have this female reproductive system. So we have cervix here, right? Cervix. So this one is the fallopian tube, right? So this one cervix at the opening here, so can have cancer. So caused by this one HPV. HPV is what is the human papillomavirus. Papillomaviruses, so also known as HPV. So this is the name of the viruses that cause this cancer. So of course, this one we have the HPV vaccine to protect lah, especially female lah. Okay, from this cervical cancer. So this is for the active immunity first. Later I will continue with the passive.